So this lesson is going to focus on how to look at a graph and determine the equivalence point, plus just giving you some general ideas on how to look at it, and then to do some calculations with these. So if we look at this first one, this titration curve, we have a strong base added to a strong acid. So here's our strong acid, and this would literally be set up where we have a flask, and then we've got our burette. And in the burette is the sodium hydroxide, and we don't know the concentration of it. And then in our flask is our HCl concentration, and that is known. So we're starting off and we're going to measure the pH in the flask. So we start off at a low pH as you would expect, and notice we slowly have an uptick as we add more and more base. And then the second that we add, where we're at the equivalence point, it skyrockets, and then it levels out again. Now to find the equivalence point from a graph, what you will do is you're going to actually take a best fit line here and a best fit line here, and you're going to look at where they intersect, or cross over rather, not intersect. And where they cross over, you're going to go to roughly the midpoint, and then that is going to be your pH at equivalence. Now notice the pH here at equivalence is 7.0, so it's considered neutral. An equivalence point means that the moles of your acid and the moles of your base are equal. And here at this point, that means, because they're at equivalence, that you've got 0 moles because we've got a pH of 7.0. It tells you that we essentially don't have any hydroxide or hydronium left over. We have just water. And so at this point, you have 0 hydroxide and 0 hydronium, and you have a pH of 7. This is always true. So if you have a strong acid, strong base titration, the pH at equivalence will always be 7.0. Same is true if you have a strong base, strong acid. But the key to remember here is that the second those change, so if one of those is weak, you don't have a pH of 7 at equivalence. But for a strong acid, strong base, you don't even have to think about it. What's the equivalence point? pH 7 for a strong acid, strong base. Always, always, always. So I'm going to move us ahead, and then we're going to talk about calculations in a few moments. And then here you can see is another titration of HCl with sodium hydroxide. This is just showing again, based on the concentrations, pH is still 7 for a strong acid, strong base. Now here, when we have a strong base, so this would be what was in the flask. So we've got our strong base in the flask, and here we've got our burette, and that has our strong acid in it. And for this particular one, you again see that the equivalence point is 7, and it should be because we have a strong base and a strong acid. I'm going to move us ahead for a moment so you can see the graph part. So here is a titration curve of a weak acid and a strong base. Now notice, this is going to be different. Notice we're starting a little bit higher. We still have our acid in the flask. We've got our sodium hydroxide in the burette. For example, if we use that, or really any strong base, so I'll just write strong base there. And so we do this titration, and when we start and we measure the pH of this solution without any strong base, it's slightly higher than a strong acid, as you would expect. And then we have this kind of buffering region, and then it levels out with a strong base. And again, you would find the pH in the same way. You would look at those where they actually come across from one another, overlap. You would find the midpoint come across, and that's going to be your pH. Now notice, it is not equal to 7. Anytime you have a weak acid, strong base titration, and you end up at the equivalence, which is not the same as equilibrium, but if you're at the equivalence point, the pH at the equivalence point is greater than, and it always will be greater than 7, and I'm going to prove it to you in just a minute. And then here, if we look at the opposite of that, where now you've got a weak base and a strong acid, so now in the flask you have your weak base, and above it you have your strong acid in the burette. You're going to take the pH beforehand. Notice it's slightly lower than where you would start with a strong base. And then you've got your buffering region right here. But again, you would look at this, come across where they come across from one another, find that midpoint, and that's going to be your pH at equivalence. Now, for a weak base, strong acid titration, the pH at equivalence, so when you're at the equivalence point, your pH is going to be less than 7. And that is true all of the time. And I'm going to show you why that's the case as well. But in general, those are sort of the things that you're going to be looking for. So when you look at your graphs after you do your lab, after you look at the lab video, you'll generate graphs and you can determine the pH at equivalence from the graph doing it just like this, where you have the two lines that cross where they cross over, finding that middle point, come across, what's the pH? That's going to be your equivalence point. So again, just reviewing, the pH of a weak at equivalence point for a weak base strong acid, always less than 7. When you have the pH of equivalence point for a weak acid strong base, it's always greater than 7. If you have the pH of equivalence for a strong acid strong base, it is equal to 7. And then in the next video, I'm going to show you why, because we're going to do a lot of different reactions, so be ready to roll.